sequence converges if the limit as n approaches infinity of a sub n is equal to 0. We did that. That's the way is equal to, is equal to L. We just take the limit of it, whatever that limit is, that's what the sequence converges to, right? But a series diverges if the limit as n approaches infinity of a sub n is not equal to 0. So what that means is, when you're looking at an infinite series and you take the limit of the nth term, if it is not equal to 0, stop right there and tell me it diverges. And remember, you're going to have to tell me why, right? It diverges because the limit is not equal to 0. Okay? That's real handy because it eliminates a whole bunch of series right off. Do you see what I'm saying? No further tests. Our test 10 is going to say, for the following sequences, determine if they converge or diverge and explain why. So the first thing you should do is you should take the limit of the nth term, and if it's 0, you keep going. If it's not 0, you just stop right there and say it diverges because the limit of the nth term is not equal to 0. That's huge, right? Okay? If the limit as n approaches infinity of a sub n is 0, then it So what I'm telling you is, in mathematics, you don't have to remember it this way. I'm going to give it to you in easier words, but in mathematics we talk about necessary and sufficient. It is necessary that the limit of the nth term as n approaches infinity is 0 for a series to converge, but it is not sufficient to show that it does converge. I'd say it like I said it behind me. If you take the limit of it and it's not equal to 0, stop right there, say it diverges, and go to the next problem. If it is 0, you haven't done anything except you know that it might converge. But if you know that it might converge, that means it also might not converge. Agree? So, you remember I told you, I wanted you to keep up with the number for the tests, and I gave you number 1, didn't I? Number 1 was a geometric series, right? Well, this one I'm going to call number 0. Why? Because it should be done before 1, right? And it's not a test for convergence. It's a test to see if it diverges, right? So I want you to get in the habit, as I have over the years, of deciding if an infinite series converges or diverges. For example, does the single word explains means yes or no is not a good enough answer? Okay? So, do you agree? Let me just remind you that what I have circled is what? I thought I might need to remind you that you're supposed to say it that fast. That is A sub n. Up here, when I talk about A sub n, I'm talking about whatever's inside the summation. Okay? And A sub 1 would be, in this case, 2. Why is it 2? Because A sub 1 is what happens when I put 1 in the place of n. And don't I get 2 over 1 or 2? Everybody follow? Okay. So look what happens. So does it converge or diverge? The limit as n approaches infinity of n plus 1 over n is equal to. Any suggestions? What is it equal to if you just substitute infinity in?
Infinity over infinity.
0?
What?
0?
No. What's n plus 1 as n approaches infinity?
Infinity.
What's n as n approaches infinity?
Infinity.
Do you hear the French national anthem playing? So, but that then is going to be equal to 1 over 1 is equal to the that's sufficient for me. L apostrophe H, I do indeed know what that means. Which is 1. Does that series converge or diverge?
Diverge.
What?
Diverge.
It diverges. It diverges. It diverges. Oh, where I got that by number 0, because the limit of a sub n as n approaches infinity is equal to 1, which is not equal to 0. That last line you could have just written, because the limit of the nth term is not 0. I don't know what you're trying to tell me. I'm picky about the way you write math for a reason. We've discussed that, and I think most of you now understand even why I try to make you do it in a disciplined manner. But I don't know what you're saying if you say the limit of the nth term is not 0. Okay? That's good enough. You get a red check and move on. Okay? Get the idea? No test. We don't have to do any of the other tests. It's over. All right? Now, this one. I'm sorry, I got ahead of myself. Everybody agree that's 0? Don't write this. Don't write that. Why?
You still haven't proven anything, you just eliminated what it can.
That's right. I didn't prove a thing, did I? All I did is, how about the big red letters? All I did is prove that it might converge. Do you follow? So don't fall into that trap. So, try telling me that on the test and see how far that gets you, that it might converge. I didn't ask you what it might do. I asked you to tell me if it converges or not. And as a matter of fact, before this class is over, you're going to know that even though that limit is 0, it diverges by number 2, which is the integral test. So this is my counter example, right? Remember I said that just because it equals 0 doesn't mean that it converges? Here's one that equals 0. It even looks like it converges, doesn't it? But it doesn't. Questions? Okay. So now we've got number 0, which is not really a test for convergence at all, is it? But it sure does eliminate a whole bunch of things. And then we've got the geometric series test. But in order to use, this is who's buried in Grant's tomb. In order to use the geometric series test, you must first have a
geometric series?
yes, thank you, William. Yes. Yes, who's buried in Grant's tomb? Answer is Grant. Isn't that it? So in order to use a geometric series, you have to have a geometric. In order to use that test, you have to have a geometric series. What's a geometric series in words? If I were going to write down in my notes how to spot a geometric series, I would say a geometric series is one in which the next term is multiplied by the next term is formed by multiplying the previous term by a constant. That's not high class math. That might not even be a good sentence, but it sure does describe the series, doesn't it? So what I'm saying is the test for a geometric series is great. It's real easy to use, and it's 100% definitive, meaning there are no mites. But it only works for series that look like what I just told you. But they're pretty easy to spot, aren't they? You know how I was doing that? They're pretty easy to spot. So all you do is you just take a look at the series and you'll quickly know whether it works or not. Okay? Now the integral test. The integral test says, I can't go to the integral test yet. Suppose I have this series.
What would you call that test you just showed us? Is there a name for it? First test?
I'd say, I never gave it a name.
Yeah, this is the first one.
You can't call it the limit test because there is a limit comparison test. How about just say limit of the nth term? Well, hang on, I'm making this up. half of the beauty of mathematics. This is where, turn around and look at Byers. This is where you do what Byers is doing. You put your pencil down and you think. That's what you do. You put your pencil down and you think. What do you notice? Anything? Yeah, the negative. There's a problem. I agree. What else do you notice?
On the fourth term, it becomes geometric.
Say what?
On the fourth term, it becomes geometric.
Exactly. On the fourth term, it becomes a geometric series, right? Does a geometric series converge or diverge?
It could do either. But I guess it converges.
You guessed right, William. Good. That's good thinking. A geometric series converges. And as a matter of fact, it's the only series that we are going to study that you know exactly what it converges to. All geometric series converge. All of them. So all you have to do is you just say, this series is geometric with R equal whatever, therefore it converges. That's all you need to tell me. That's test 2. I mean test 1. Now, if I ask you to find the sum of it, you can, can't you? But remember, I told you this test is about does it converge or not. So do you agree from the fourth term on it converges? Does everybody agree? But here's my question to you. Suppose I did this. Suppose I did that. Josh, does part 2 converge, yes or no? Yes. It was Josh that first spotted that that's a geometric series, right? Everybody agree? Everybody agree? So, part 2 converges. Uh-oh. That one sentence gets you a red check. Now, be careful here with your answer. Be careful with your answer. Put your thinking cap on. As I tell my 102 classes when I used to teach 102, as long as it's not a Yankees cap. Put your thinking cap on. Does part 1 converge or not? Does part 1 converge or not? Anybody want to be brave enough to go first? Well, let me restate my question. How could part 1 possibly not converge? How could it keep from converging? 1 plus 4 is 5, minus 2 is 3. Does that converge or not? Yes or no?
I'd say it doesn't matter because it's the very beginning of the.
That too. That too. But my point is, it converges. It converges to 3. Don't you just add them up? I want that to be the obvious reason why it converges. So I'm going to say part 1 converges because we get 3 for the sum. What I'm telling you is if you can just add it up, don't you know what the sum is? And therefore it converges to that sum? Okay? Now, what Williams said was, did I get the quote right?
Mm-hmm.
What Williams says is, it doesn't matter anyhow. Why? Why? Whatever those 3 terms do compared to infinity, does it matter? Do you see what I'm saying? Everybody? Okay? I agree with William. One more. What are we studying? What kind of animal is it that we're studying right now? What are we studying? If your mom wasn't a math teacher, and you went home and your mom said, "What are you studying in Cal 3 now?" What would you tell them? And don't tell me you'd say BS. Go ahead. What would you tell them?
Sequences in series?
Yeah. What kind of sequences in series?
Infinite?
Yeah. Is part 1 infinite?
No.
So how could it not converge if it's infinite? Follow what I'm saying? Everybody? If it were 100 terms, wouldn't you just start adding? And whatever you get's what it would converge to? So you put all of that together and see if this is not true. Agreed? If we're dealing with infinite series, and it's not convenient for me to deal with the first 3 or 4 terms, back to Williams number 2. It just doesn't matter. Because what is important is what happens out at n as n gets towards infinity. Everybody follow? Everybody okay with that? So it was Josh that first quickly spotted, that from the 4th term on, that's a geometric series. So now you know what I would have done is I would have taken my pencil and drawn a line through the first 3 terms, and I would have said, ignore these. You get the idea? Everybody? Okay? That's handy. That's handy. It's real nice. Don't you wish we could have done this in Cal 2? And that is, if we have an integral that we can't integrate, just ignore it. Or just change it to one that we can integrate. Wouldn't that be nice? This is one of the few times in math, if you don't like it, just ignore it. Scarlett O'Hara, tomorrow, and Gone with the Wind. Meaning, things aren't so hot right now, I'm just going to ignore it and think about tomorrow. Isn't that what I'm telling you to do? And you should be thinking that doesn't happen very often in math. Huh? Okay? All right, there's another thing you need to know about series. This is important because I'm going to use it, and I'm going to remind you that I can lop off the first 3 or 4 or 5 terms. I can lop off numbers 1, 2, and 3, and 6 if I don't like 6. I can, I can, whatever I want to do. Okay? As long as it is a finite number of terms. What does a finite number of terms mean?
Not infinite.
Not infinite, exactly. A number, right? I can eliminate 5 terms, or I can eliminate 100 terms. I just can't eliminate an infinite number of terms. Remember that. That's going to get you out of a jam at the end of this section. Here's another one. We're going to keep this simple. Well, hang on, I'm making this up. Everybody agree that's what that is? I picked the easy one. What do you get? Where do you start when you substitute in?
4.
4. So when you put 4 in, what do you get for the first term?
1.
All right. You made me work for that, Byers. But you usually do. What's the next number after 4? 5. If I put 5 in there, what do I get for the next term?
1/2.
And guess what? I'm describing the same series. But with a different index. Didn't I tell you when we first started doing this that the little n was the index for the sequencer series? And I changed the index. You want me to tell you my secret forever and ever? It works every single time. You will never miss a re-indexing problem. This number right here and this number right here, from here to here, was up 3. Yes or no? This number from here to here was what?
That's 3. Down 3.
Did I tell you you'd never miss it? You can re-index anything you want to by going up on one and down on the other. I could just as easily have had, could just as easily have had down 3 right here. And if I did, I'd have had to have had up 3 right here. You follow? I don't know why textbooks don't put that in there. It makes it so easy. What you're doing is, aren't you just changing the starting point? That's really all you're doing. Questions?